Hello, and thanks for watching. This demonstration comes from Roto-Disc and illustrates the seat replacement and adjustment process for the Roto-Disc valve. This process applies to any soft-seated Roto-Disc or Roto-Disc 2 valve, regardless of when it was supplied. A soft-seated valve is a valve with a PTFE, TFM, Teflon, PEEK, Nylon, or any other plastic-type seat. This process does not apply to a hard or metal-seated valve, such as a valve with a stainless steel, carbon steel, bronze, Hastelloy, or other metal seat, nor does it apply to a valve with an inflatable seal, such as our Rotoflate or Rotovert valve. The valve we are using today in our demonstration is a 6-inch Roto-Disc valve. Here we see the valve body. This is the dome. This is the seat retainer, and these are the cap screws. The seat sits directly below the seat retainer, and below the seat are the valve shims. We will describe the use of the shims in a moment. The first step is to take out the cap screws. This can be done by hand with an Allen wrench or more quickly with a drill. With the cap screws removed, rotate the dome in order to more easily grab the seat and the retainer. Now remove the seat and the retainer. Here you can see the seat, the retainer, and the shims. The shims are installed during the assembly and calibration process and are used to obtain the proper seat compression. The number of shims used varies slightly from valve to valve, but will normally be around 26 thousandths of an inch, made up from a series of 3 thousandths and 5 thousandths inch thick shims. Once the seat is removed, evaluate the sealing surface of the seat, typically wear occurs on the sealing surface, shown here. In instances where a quick fix is needed because a replacement seat is not available, the sealing surface can be improved by simply taking an abrasive pad, such as a fine grit sandpaper or emery paper, and rubbing it along the sealing surface. When doing this, make sure that equal amounts of grinding are done on all areas of the sealing surface rather than just where the wear is evident, so as to avoid creating a gap in one area of the seat. Now we will demonstrate the process of installing and calibrating a new seat. Note that we have created a clearance on the bottom of the valve to allow space for the dome to rotate. Here we are showing a new seat and also a full shim pack. Shim packs are usually sold with a new seat as a kit, though a seat can also be ordered individually. A full shim pack will have 32 thousandths of an inch total thickness, made up of 4 5 thousandths inch thick shims and 4 3 thousandths of an inch thick shims, and will be shipped with cardboard packaging. The cardboard pieces should not be installed in the valve. The shim arrangement, meaning the number of shims that should be used, should match the original shim arrangement. The shims themselves are not a wearing part, since they are not in the material flow path, and so in most instances, the original shims may simply be reused. It is possible, however, that a few shims may need to be added or taken out to obtain the proper seat calibration. We will describe this process in a moment. The next step is to place the seat and then the retainer into the counterbore of the valve body. You will need to line up the holes in the shims, the seat, and the retainer before installing the cap screws. Next, add the cap screws in 4 places, equally spaced around the circumference of the retainer, and tighten them just slightly. This should be enough to engage the seat against the dome. Now, rotate the dome. The valve should rotate easily at this point. If it does not, then do not try to force it, since this could damage the seat. Rotational resistance is an indication that the seat compression may need to be changed, and we'll go over that process in a moment. Assuming the rotation is smooth, then go ahead and install the remainder of the cap screws. We recommend a cross-pattern installation process, and also rotating the dome a couple of times while installing the cap screws. There is not a specific torque requirement for the cap screws, though once they are all installed, there will be significantly more compression on the seat, and the valve will require some effort to rotate. Now, rotate the valve to the full open position to confirm that the rotation is smooth across the entire stroke. The dome should rotate only to the point at which the leading edge is level with the top of the seat retainer. Do not rotate the dome to the point at which it disengages the seat, as this may cause damage to the seat when the dome rotates closed. Okay, as we mentioned previously, there may be instances where the seat compression has to be adjusted in order to obtain the proper performance. The first thing you will want to do in this case is adjust the torque on the cap screws to see if this achieves the desired result. The cap screws work in conjunction with the shims to set the seat compression. More torque means more compression, and less torque means less compression. If adjusting the cap screws isn't sufficient, then you will need to change the shim arrangement by adding or removing shims. Adding shims will raise the seat off the dome and therefore decreases compression. Removing shims allows the dome to sit lower against the dome and therefore increases compression. To do this, follow the disassembly and reassembly steps outlined previously in this demonstration and add or remove shims as necessary. Typically, no more than 5/1000ths of an inch total shim will need to be added or removed with the new seat. As mentioned previously, in most instances, the existing shim arrangement works best when replacing the seat. A properly shimmed valve will offer the most resistance at the beginning and the end of the stroke and should be even across the middle of the stroke. A valve in sensitive applications where it is to seal against a gas pressure differential may need to undergo pressure testing in order to ensure proper seat compression has been achieved. Thanks for watching.